Hi, and welcome to this segment where I would like to look at consistency of linear systems. So when is a linear system said to be consistent? A linear system is said to be consistent if it has at least one solution. Alright, please note that this implies that even if we have more than one solution, this linear system is still consistent. And then when is it going to be inconsistent? It is going to be inconsistent if the opposite occurs, i.e. it has no solution. Okay, so when is a linear system going to have no solution? Graphically, from simple problems, maybe if we just have a problem in 2D, it will be the point of intersection of the two lines. Point of intersection of two lines. Okay, maybe if it is in 3D, it would be the point of intersection of the plane, of the planes. So where the planes intersect, then that is maybe where I have the solution. And then here where the lines would intersect, that is where you will have your solution, maybe xy. Okay, but if it is more than that, of course we cannot use just these graphical illustrations. But the good news is that we can always use the Gaussian elimination processes to help us identify whether a system is consistent or inconsistent. For instance, let us consider this augmented system AB, and then we carry out the row operations which we have looked at before, and then we come up with this system here. Okay, the elementary form and then the right hand vector. Okay, now if a situation arises whereby in this form here, A, C, reduced form, okay, we have a situation where the first non-zero entry occurs in the last column. Okay, we have a row where we have something of this sort, where the first non-zero entry occurs in the last row, i.e. in other words, alpha is not equal to 0. Then this system is inconsistent. Why is it inconsistent? It is inconsistent because we have a situation where we have the left hand side and then we have the right hand side. The right hand side is alpha, which is not 0, and then the left hand side is 0 because the coefficients are all 0. Okay, so 0 xn is 0, so we cannot say, so we have 0 on the left and then on the right we have something which is not 0, so we have inconsistency here. Okay, that is not going to work. Please note that if you have zeros everywhere throughout, that's fine, that's consistent, because you have on the left you have 0 and then on the right you also have what? 0. Okay, that balances out perfectly. Even if you have a situation where you have a non-zero and then on the right you have a 0, that is still consistent. Okay, yeah, because you can simply see that the only solution for the left hand side, the only coefficient for the left hand side, if you have something of alpha xn equal to 0, then you know that alpha will definitely be equal to what? To 0. Alright, okay, what else? Oh yeah, we can use the ideas from, let's see, from our rank. Remember, let me see. Okay, let us write down something here. If the rank of the augmented matrix here, okay, is the same as the rank of the coefficient matrix A, then this system here is consistent. Okay, so why would we say that this system here would be consistent? Remember that the rank, when we say the rank is the number of the pivots. Okay, and remember that the pivot is the first non-zero entry in each row. The pivot is the first non-zero entry in each row. Okay, so if you have a situation where the pivot, actually in here, this situation here, we can as well say that alpha is the pivot because it is the first non-zero entry in this row. And remember, this system here is in echelon form, so everything else below is 0, 0, 0, 0. That means that the first non-zero entry here is in the last column here. Okay, it is in the column of B. It is the pivot appears in the in the right hand vector B. So if such a scenario happens, that would imply definitely that the rank of AB is not equal to the rank of A, because for the rank of AB we have a pivot which appears also in this right hand vector, and yet of course A, since A does not contain B, the rank is definitely going to be 1 less or something of that sort. Okay, so if the rank of the augmented matrix is equal to the rank of the coefficient matrix, then we have consistency there. Okay, so now in summary we can say that consistency is going to, we are going to have consistency if such never happens. Okay, if such never happens, where alpha is not equal to 0. Okay, if that happens, we don't have consistency. Okay, and then what else? We are going to say that if the rank of AB is the same as the rank of A, then we have consistency. Okay, good. So next, let us look at a simple example here. Okay, so we'd like to determine if the following system is consistent. So please allow me to, for time's sake, just write down the augmented system. So for augmented system, we have one, let me say 1, then we have 2, 1, and then on the right hand side vector we have 1, then we have 2, 4, 3, 1, and then we have 2, 4, 2, then we have 3, 5, 8, 3, 5, 8, 6, 5, and 3. Okay, so now you are going to carry out the row operation. Okay, then you reduce it to its reduced form. Okay, and then please allow me to write down the reduced echelon form here, which we have as 1, 1, 2, 2, 1, and then we have 1 here, then we have 0, 2. Okay, we will just write down its reduced, its row echelon form, not the reduced form, because either way this can also work. Okay, yeah, this is 0, 0, 0, 0, 1, and then we have -1, and then we have 0, 0, 0, 0, 0. So what are our pivots? 1 is a pivot, 2 is a pivot, and okay, how did I write this? Must have a 0 here and then a 0 here. Okay, so this is its row echelon form. Okay. Okay, so clearly we can see that yeah, okay, if this is enough for us to see that the system is consistent, because this is consistent, there's no problem with this is consistent, there's no problem with that, this is consistent, there's no problem with that. Our only worry was looking for a row where this is going to occur, okay, and where alpha is not equals to 0. Okay, so clearly, since this does not occur, we can know that this system here is consistent. So you can go ahead and answer the rest of the questions, which you said maybe the rank, the basic columns, can you find the linear combination, i.e. how you can express the non-basic columns in terms of the basic columns. One other thing here we can note is that we have that the rank of A is the same as the rank of the augmented system here, and which is what? 3. Okay, even if you had deleted this column here, okay, you would still find that the rank of this would be 3, and even if we add it again, we would still find that the rank of the augmented system is still 3. Okay, so indeed this system here is consistent. So in future you could be asked like to make modifications on some of these parameters here such that the system is consistent, or what would this parameter be so that the system is not consistent, and so on. So just understand the idea here of when is it consistent, when is it non-consistent, and then you can always, follow through the rest. Okay, all right, thank you so much.